Okay, so in this video we're going to be looking at the independent samples t-test, and you can follow through this example on the website. So what the independent sample t-test is basically doing is comparing two means, the mean on a particular dependent variable for each of two groups of an independent variable. So in this example we're going to be looking at comparing males and females, so the independent variable will be gender, on age 14 exam scores, so seeing if there's a difference between the mean age 14 exam scores between males and females. So I guess the null hypothesis is that males and females aren't different, they're essentially the same population, at least with regard to this dependent variable. So we're going to see if there's a statistically significant difference between the two groups. So let's run you through how to do this. If we go up to Analyze and then to Compare Means, and it's an independent samples t-test. Now there's lots of different types of t-test here, but independent samples is when you've got two different groups and there's no overlap between the two groups which you wish to compare on. Okay, so we open this up here. So our test variable will be key stage 3 standardized score, so age 14 exam score, and our grouping variable will be gender. Now before we move on, you'll see here you've got these two question marks. What SPSS needs to know is which actual two groups we want to compare within gender, and you need to put in the codes. So if you remember, for gender we've coded 0 for males and 1 for females. Of course there's only two groups in gender, but you may want to do an independent sample t-test where you've got a independent variable that has multiple groups, which is why you need to define these groups, why you need to specify those groups. So I think that's all we need to do, so we'll just press OK to run the analysis. So let's have a quick look at what output we get. You'll see first you get the group statistics, so you can see how many males and females we've actually included in the analysis and their mean score. Now if you remember, for age 14 it's standardized such that the mean score is 0, so you would expect one of the groups to have a minus score. You also get the standard deviations and the standard error there. Moving on to this very wide table here, this is what we're interested in with regard to whether the two groups are different to a statistically significant degree. So the first thing we need to look at is what's called Levene's test of equality of variances. Now this is basically testing the assumption that the null hypothesis, if you like, that there's equal variance between the two groups, because if there's not equal variance we have to slightly adapt the type of t-test we use. We don't actually have to do anything, it runs both t-tests, but we need to look at this value here to see if we need to look at the first row, equal variance is assumed, or the second row, equal variance is not assumed. Now because the test is statistically significant, that means that we reject our null hypothesis that the variances are equal, so we need to use this second row here, equal variance is not assumed. If we run along to this part, we'll see that there is a statistically significant difference between the two groups. So this is far less than 0.05, it's actually less than 0.0005, and we'd report this t-statistic just as a matter of interest for our readers. But really the key message here is that yes, there is a statistically significant difference between the scores at age 14 for males and females. Now one thing to quickly mention is that statistical significance doesn't tell you anything about the effect size, so we don't know how big the difference is. I mean, we can have a guess by looking at the actual differences between the means, but we'd need to calculate something like Cohen's d to get a better idea of what the actual effect size is.